Welcome back to SBL. Last time we talked about first principles and deriving the equation and understanding it. Today we're going to run through an example of calculating the derivative of x squared using first principles. So let's get to it. The first thing we're going to want to do is write down our first principles equation. So if you don't remember it from our last video, you can check the video here to learn all about how we drove the first principles equations. If you just want to write it down and you don't really care about how we got it, this is the first principles equation. And basically we are just going to use this function, find the derivative of x squared using the first principles equation. So purely algebraically, what we want to do is we have all these parts to our equation. If we want to box them up, we have 1, 2, and let's call this 3. So 1 is f of x plus h, right? And so what is that? So in our question, f of x is x squared, right? So if f of x is equal to x squared, then wherever we see the x, we're going to put the x plus h. So f of x plus h is equal to x plus h squared. Cool? So that is our number 1. Cool? Number 2 is just f of x, which we know is equal to x squared. And h, we just leave as h because we're taking the limit as h goes to 0. So eventually our h is going to disappear. So now we're going to write this into the equation. We're going to say x plus h squared minus x squared over h. And we're taking the limit as h goes to 0, right? And so what we're going to do from here is I'm going to expand out this because we have to simplify this whole equation. If we took the limit as h goes to 0 right now, we'd have a 0 on the bottom, and we can't ever divide by 0. So we do have to do some things to this to be able to sub in h as 0. So what we're going to do is expand this out. So x plus h minus x squared all over h, and we are still taking the limit as h goes to 0. Cool. I'll draw a little squiggly line here for you guys to separate it. And so after we expand this out, we get the limit as h goes to 0. And if you're having trouble expanding it out yourself, pause the video, see if you can FOIL this out yourself. And if you do need some help on this, I can also make another video on it. So as we're FOILing it out, we get x squared plus 2xh plus h squared minus x squared all over h, where all this stuff, okay, all this stuff here was that. So if you do want to do it yourself, you can check if you got the same as me. And so as you can see from here, the x squared and minus x squared cancel. Cool. And then we have 2xh plus h squared all over h. So we have the limit as h goes to 0 of 2xh plus h squared all over h. And what we can do here is we can actually factor out an h. Cool? And then we have this all over h, right? And the h cancels. Mind you, we're still taking the limit. Sorry, I keep forgetting to write it. Usually I just write it at the end. The h cancels, and now we get that our big function, cool, because I wrote big F up here. So our big function is equal to the limit as h goes to 0 of 2x plus h. And so if we sub in the limit as h goes to 0, as this h turns into 0 and disappears, we just get 2x. So now we can say the derivative of x squared, cool, the derivative is equal to 2x. So we're done this problem. We solved it algebraically, so you can stop watching if you want, but I am going to graphically show what this actually means. So now that we have our function drawn, x squared, which is the one we were looking at, we're going to see what the derivative of 2x actually means. So if we get our function 2x, and we also plot that, so that has a slope of 2. So 1 over 2 up, right? 1 over this way, 2 up. So this is our line. So this is our line here, right? And so basically what happens is this line, the derivative 2x, cool, 2x, so if you pick any point on the y equals x squared graph, the tangent at that point is going to be equal to the slope on this graph. Cool? So if I wanted the slope of the tangent line, cool, at x equals to 1, if this is x equals 1, right? I know that the slope of this tangent line to the x squared graph is going to be f prime of 1, which is going to be 2. And you can see here that at x equal 1, 2x is equal to 2. Cool? And you can see here at the bottom of the parabola turn, right, our slope is 0. And so you can see the function y equals 2x, at 0 the value is 0. So that means the slope of the tangent line at that point is also 0. Right? And as you can see, that this value of the function is negative after 0. And on the parabola that we see here, the slope of the tangent lines are negative and negative and negative until it reaches 0 at the vertex, and then the tangent lines become more and more positive, which is what this y equals 2x is telling us, is before 0, our slopes are super, super negative, and then the values of the slopes of the lines are coming towards 0, and then right here at 0 where they meet, that's actually telling us that we have a minimum on the function. The slope is 0. And then now our slopes are becoming positive. This also tells us that when the derivative equals 0, we also have a local minimum or maximum. Because as a function goes like this, the slopes of the tangent lines will eventually equal 0, causing our functions, the derivatives of those functions, to hit 0 at that point. Thanks again for listening. This was a great video of an example of using first principles. If you did miss the first principles video, you can find it right here. If you need any help with any more questions relating math and science, drop them down in the comments below. If you liked what you see, please subscribe. I'm going to be doing a lot more calculus, derivatives, integral videos, some physics videos as well, magnetism, all that fun stuff. So if you're interested, please subscribe. Give me some more ideas to do videos on in the comments below, and we'll see you next time.